Welcome back everyone to the lecture about applied parameter analysis. So this is the second part, Python programming, basics of Python programming, and we will have a look at conditions, data structures, loops, and functions. Conditional statements allow us to differentiate scenarios, and similar to the for loop I introduced to you last week, you see again indented code after an if statement and a colon by the end of the line. What is kind of new, you could say, we can leave out the brackets here. I sometimes set them because then it looks similar to what I'm used to. So feel free to do this. And we can basically, like an image macro, like we learned earlier, we can check variables if they have certain values or if the values are in particular ranges. And there's also an else statement which allows us to execute some code in a different, in case of the condition is not fulfilled. Furthermore, what is quite practical in Python compared to, for example, ImageJ, is that we can write more intuitively, for example, checking a variable for a range. So we can really say if 80 is smaller than quality, smaller than 90. So if quality is between 80 and 90, then we can print out, for example, a text. So this is more convenient than an ImageJ macro. That was more complicated to write things like that. But in basic, in principle, the procedures behind are exactly the same. Furthermore, this is a recap from last week and also a little correction. Arrays. So arrays are in Python actually called vectors, lists, and collections, and there's differences between vectors, lists, and collections. And I would actually not go deeper into this to be not too confusing. So let's, for the moment, just keep it like that. We have arrays, we can create arrays like we did last week. That's just a recap, right? We can define arrays with these rectangular brackets, putting numbers in between, and we can print them out. We can change array elements by specifying them. Again, we start from 0. So the first element in this array is this number 2. So if I replace it by a 5, then I get this new array out. And I can also read array elements. For example, if I write that, just the last element, the element number 2, 0, 1, 2 of our array is printed out. Furthermore, there's a structure called dictionaries. This is something which really does not exist in ImageJ. And you can imagine this data structure is like a dictionary between languages. So let's define a variable, which is an English-German dictionary with these curly brackets. And we have now an English word, probability, colon, and a German word, Wahrscheinlichkeit. And then we have more entries. The dictionary is a long thing, right? There's many entries in there. We have another English word called likelihood and colon and Wahrscheinlichkeit. And here you see that the elements on the left, the so-called keys in the dictionary, must be different, while the values, that's the elements on the right, can be the same. This is, by the way, a German-English problem we have. So for us Germans, it's the same term, even though in English language there's different concepts behind, different words behind. Wahrscheinlichkeit versus probability and likelihood. And if I print out a dictionary, I can read it like that. So I have here again my curly brackets, and then I have my key value, key value. We're also talking sometimes about key value pairs in a dictionary. You can also address elements in the dictionary like arrays. It's a bit like arrays, even though it's a dictionary in behind. So let's look at this dictionary. We have a dictionary here which has a key called first and maps against this key the value number 1. And we have a key called second and we map against the value number 2, and we have third and 3. And we can now add a new element to this dictionary by, for example, writing here dictionary rectangular brackets. This looks like an array, but it is a dictionary, and we can here now put our new key, and we can, for example, add a value number 4. And when we print this dictionary out, we see here first, 1, second, 2, third, 3. So this is the 3 key value pairs which were there from the very beginning. And we can add another one at the end. That's what we just did, and then it reads like that. So this is dictionaries. And to totally confuse you, we can combine these structures with each other. So for example, we can have a dictionary of arrays. So we have now here, this is the key, something, colon, and this is the value. So the value does not have to be a number or another string. it can also be an array again. So, and if we have also something else with a different array. And if we print this one out, we will then see this is again our key. Something value is this array consisting of 1 and 2, and something else is the second key containing an array or linking to an array 7 and 8. And if you want to access now one particular element in the array, in the dictionary, you can write something like that. So the dictionary of arrays, rectangular bracket, a key. So this is one of these here at the very left. And then the index in this array in another pair of rectangular brackets. And if you print then this one out, you see that this 5 here changed compared to the original dictionary. You may not do that in your exercise, or you may, if you like. I'm just mentioning this combination of different data structures because it is very popular in Python, and you may see it in example code. So if you at some point you work with some data and you print it out and you see these these curly brackets, something colon and rectangular brackets, you should know what that means. That's why I'm introducing you to these arrays and dictionaries, so that allows you later to read that and to deal with what is in there, especially when working with tables, and we will do this today. You will see this concept again and again, and that's why I wanted to explain you a little bit the background behind. Furthermore, for loops, that's also a recap from last week. So we can iterate over collections in for loops. So for example, for every animal in our collection of animals consisting of dog, cat, mouse, we want to print that out. And this is what then basically happens. We can also enumerate elements in an array. Very popular in Python. Many people do this. I personally have a bit issues with reading it, but I nevertheless wanted to show you in case you get the taste. We can now, for a pair of index and animal, in an enumeration of our animals, can go through this enumeration of animals and can print that out. So it gives us basically, I print now out the animal number string of index. So this is the first one here. In the list is the animal. This is the second variable here. Then it prints out something like that. Animal number 0 in this list is a dog. And animal number 1 in this list is a cat. Yeah, so this you can enumerate giving numbers to the elements in a list, in an array, in a vector with the enumerate function. Furthermore, and this may be relevant for today if you want to do some statistical analysis on pairs of measurements, you can group pairs together. You can zip them. You can zip arrays together with the zip function. Same principle for two variables m1 and m2 in zip measurement 1 and measurement 2. And you see measurement 1 and measurement number 2, that's two arrays containing, I think actually containing the numbers I showed in the very beginning of the lecture today. And then we go through them pairwise. Yeah? So for example, if you want to calculate the difference between these pairs of data, then this is the way to go. And for just showing how to print them out, so paired measurements, I print out measurement number 1 and measurement number 2, and I convert them to a string before so that I can combine all this in the long string. And then you see here paired measurements 1 and 4. So this is 1 and 4. Paired measurement 9 and 5. This is 9 and 5. So it's really like going through two arrays with one for loop. In ImageJ macro, that would be quite complicated. In Python, they have this zip function easing your life here. Then that might be a helpful code snippet. So I copy pasted here an ImageJ macro snippet from lecture number 4. This is the ImageJ macro, which allows you to go through a folder, through a list of files representing a folder, and printing out the file names. And here you see the Python counterpart to that. So also here you have a variable which contains your folder name. Then, like in ImageJ, you have a function which gives you a list of files from this particular directory. And then you can, with a for loop, go for every file name in this file list. So this reads a bit more convenient compared to in other programming languages. And this is what many people highlight as the cool thing about Python, that you can read that in a more human readable way. Furthermore, you can then check if, for example, a file name ends with TIFF in order to find out if it is an image. That you all did that in the exercise, I guess, and only print out the TIFF images in a particular folder. So this is relevant for an exercise today, and that's why I give you this little code snippet here before you start assembling it yourself. That might be faster like that. Furthermore, custom functions. I showed you earlier on ImageJ and I said it's not really necessary for any exercise. I think in the Python exercises it will become very useful soon if you understand this concept and if you use it, because it prevents you from replicating code. You can take a certain functionality, like for example the mathematical complicated operation of the sum of two numbers, and you can put it in a function. So you define a function called sum. It has two parameters, a and b. Then you do a certain procedure with a and b. So for example, you sum a and b and you return it back to the place where the function was called from. And this is the other side how it looks like. This is how you call a function. You can, for example, call the sum function with the parameters 4 and 5. And the result which is returned from this function will be put in the variable c. And then you can print out c. So this is basically what functions do for you. So in case of a sum, it may be super trivial, but it might be more helpful, for example, if you want to use a function which shows an image. So we will do image processing in Python today, actually on the coming slides. You will realize that again and again you have to call two functions for showing an image. So maybe you want to combine these two functions, the imShow and the show function, in a show image function you define for yourself. And then at whatever part in your code, you can just call this function for showing an image. So this is what we will do next. I will explain it a bit more in detail. I'm just saying that when you call the same code again and again, if you have 3-4 lines of code and you copy paste them from one place to another and you do them again and again, you may want to define a function and then just call this function instead of repeating the code over and over. And then there's a thing, I mentioned it last week already, there's a thing called Jupyter Notebooks. This PY, it's not a typo, it's Python. And Jupyter Notebooks is basically a tool which runs in the browser and gives you the chance to write a little code block and to see the result of this code block just below. And basically you will realize that most of the slides I made so far about Python are made with Jupyter Notebooks, and that's why I would like to introduce you to this technique, which will also allow you to document your code in a way maybe that helps you understanding it. And what you should furthermore know about that is you install it with conda install Jupyter, and then from the command line you can start it with Jupyter Notebook. I will show you in a second what it does. And there is some practical shortcuts I will also introduce you to. So this is my command line, you know, from last week. You see here that my base environment is activated. So first of all, I would like to create an environment for the exercise today. So that's conda create -- name exercise 10. And then I can call conda activate exercise 10. And now I can install stuff. So for example, I would like to conda install Jupyter. And then it downloads everything which is necessary for running Jupyter Notebooks. Furthermore, what we will need today, so I will just conda install numpy, matplotlib, pandas, and scikit-image. And you will see during the following slides what these packages do, but I will just install everything at once. So after installation of all the packages we have, I can show you again how the cd commands work. So I'm now in my lecture applied bioimage analysis folder, and I want to go to cd lecture number 10. So that means I just enter cd10 and then I press the tab key so that it auto completes the rest, because I don't have to type the whole folder name then. And then this is how you start Jupyter. So you just enter Jupyter space notebook, and you will see a browser is opening. So we see now the folder where we are in a browser. And you see here, so for example, you see the PowerPoint file, which we are just looking at. And furthermore, you see some files with the ending IPYNB. So this is Jupyter Notebook files. And I would like to first show you how to create a new one in order to give you an introduction of how notebooks work before we look in the existing ones. So a new one you can, for example, create by clicking here on New and selecting Python 3. So a new tab opens, and you now see the window like that. the first thing we should do, we should enter here, instead of untitled, we should enter a name. So this is our first Jupyter notebook. And then you see here these certain cells. So the first command, so this is a code block where you can enter code. So the first command you would like to maybe enter would be a print hello world. And the most important shortcuts you may want to know is Shift Enter, because Shift Enter executes this particular code block. And I would recommend you, especially at the very beginning, to put independent little code snippets you are trying out really in new code blocks. So you may, for example, also want to play a bit with variables. So you write something like a equals 5 and b equals 7, and then you can print out a plus b, yeah, and Shift Enter executes this particular code block. And you may at some point come to the situation where you want to take some notes about what you're doing here. This is why notebooks make so much sense. So for example, I can change, instead of code here in this pull down, I can also say Markdown. And Markdown is a language for describing text formats, kind of. So you can, for example, take the hash symbol and write a headline. And you see already it's a bit formatted because this is normal text. I can also make bullet points. Yeah. And when I again press Shift Enter, then I can read my text in a formatted way. So this may help you in documenting your code exploration, kind of. So whenever you wrote something useful, like for example this code snippet was like, okay, I understood now how math is working in Python. You click on the cell above and you click on plus to add another cell in between. You change this cell to Markdown, and then you say, okay, math in Python. Shift Enter. And so you can categorize it with the code blocks you are writing in order to give the whole thing a readable and nicely human readable structure. Furthermore, you can also add a new block after and say something like Markdown here, and write down some detailed explanation. Shift Enter, and then you can still move these blocks around with these keys here for going up and down. If you want to delete a block, you have to go to the edit menu and delete a cell. So you can also, with Shift and the arrow keys, you can also select several of those and delete them, for example. So this is actually quite practical in order to have a visualized way of Python code and for taking notes and stuff like that. And what is actually the very practical part about Jupyter Notebooks is they allow us to exchange code in a way so that others can read it and can reproduce our procedures without sending them just this Python file, which is a bit abstract visualization of that. So I would like to show you all the plots I did in the other part, in the Blunt-Altman analysis lecture part, exist as a Jupyter Notebook, and you can follow what I did in a Jupyter Notebook. So I return to the other tab in my browser, and I open the Blunt-Altman analysis Jupyter Notebook. And you see here I wrote some headlines. I have here my measurement A and my measurement B. And I create from that a data frame. I will show you what data frames are just in some slides in the future. And then I can print out this table here. The table you see here is basically the table I put in my slides. Then I go further and I measure the mean. So this is the NumPy function for measuring the mean from measurement, and I printed it out. And you will see in my PowerPoint slides also this comes from this Jupyter Notebook. So you can now reproduce the science I did for generating my slides and for explaining you how Blunt-Altman plots work. You can understand all that by going through my Jupyter Notebook. Furthermore, and this is, I really recommend you, when you go through this and you try to understand it, maybe you ask also a question in the next Zoom meeting. If you want to take notes here, just add another paragraph, turn it to Markdown, and take your personal notes here. Yeah, so Shift Enter to save it. So this is kind of for you. You can take the script from anyone for comparing measurements, for drawing plots, for making histograms, for measuring the correlation, and so on and so on. You can read the code in very detail. You can put another comments in between. You can print more values out. You can adapt all that in this nice Jupyter nice Jupyter notebook. And for example, if you want to draw a Blunt-Altman plots, if you Google for Blunt-Altman plots in Python, you will end up on this website which gives you this custom function. So that's why I introduced you to functions earlier. You can take this custom function from the website, from the internet, put it in your Jupyter notebook, and then you can just call it with two measurements. So this is one reason why Python is so popular. You can just download a Jupyter notebook. You can just take a code snippet from somewhere, put it in a cell in a Jupyter notebook, and execute it. That's actually very helpful to make reproducible signs, to exchange data analysis procedures between different people. Okay, that's it so far. The next part will be about bioimage analysis with Python and in particular with scikit-image. So see you soon.